Hello everyone, and welcome to today's chem lesson. Today we're going to take a look at precipitation reactions. Now, a precipitation reaction is a reaction where you mix two soluble substances and get a product that is insoluble. Right, a reaction where you mix two soluble things and get something out that is insoluble. You create an insoluble compound that falls out of solution, and that is called your precipitate. Now, in order for us to look at what is soluble and what is insoluble, we need to remember our solubility rules. We need to take another look at table F. So let's do a couple of things just to warm ourselves up, right? First, AgCl, is that a soluble compound, yes or no? Silver chloride is insoluble. It is not soluble. Chloride is normally soluble, but silver is one of the exceptions, making this combination insoluble. What about lithium sulfate? Is lithium sulfate soluble or insoluble? Lithium is a group 1 ion, which means that anything it connects with, anything it creates a compound with, will be soluble. Let's look at an example that takes place in a picture. Lead nitrate is a soluble compound. If I put lead nitrate in a cup of water, it will dissolve. I will get lead ions. I will get nitrate ions. Looking at table F, that's because nitrate is always soluble. It's a soluble substance. It has no exceptions. In this second cup, we've got sodium iodide. Again, a soluble compound. It has broken up. It has become ions. The Na and the I are separate. This is because sodium is a group 1 ion. Soluble all the time. No exceptions. Now, when we take these two cups and pour them into one bigger cup, we get new possible pairings. The lead was already with the nitrate, so this is a pairing we've already looked at. The lead is positive and the sodium is positive, so this is a combination we can't look at. But the lead and the iodine can come together and interact, where before they couldn't, right? In two different cups here. The sodium and the nitrate can come together and interact, where before they couldn't because they were in two different cups. And when these new pairs get formed, one of the substances that we make, the lead iodide, is insoluble. If we look over at table F, iodide is a halide, right? It is normally soluble, but it's not soluble when combined with a lead plus 2, which is exactly what we have here. This makes our precipitate, right? It creates an insoluble pairing that will then settle out of solution. It will fall to the bottom as this kind of nice looking yellow powder. The other pair, sodium and nitrate, are soluble together, so they actually don't do anything. They remain aqueous. Every combination of sodium with something else in this cup is soluble. Every combination of nitrate with something in this cup is soluble. So these just kind of sit there. They spectate, right? We call them spectator ions, because they just sit and they watch. They don't do anything. Now, while that is all well and good, what if you're given an example? What if you're asked to fill in the other side of an equation? Now, if we want to fill in the other side of an equation, we want to look at something like this and get the answer, right? What does the other side look like? We need to do a little bit of work. First, right, let's make a list of steps here. First, we need to take apart our ions, right? Take apart our reactants. We need to figure out what are the ions that make up these substances. Second, we need to swap the partners. It's a double replacement reaction, so our positives need to swap places, or our negatives need to swap places. Third, we need to put our products back together. Right, we took them apart, we looked at the ions that were there, we swapped them. Now we need to recreate compounds. Right, we need to put back together our products. Lastly, our last step is to balance our equation and check table F. We need to see if there were any actual precipitates that formed here. Right? It's a precipitation reaction. We need to check to see if there are any precipitates. So let's do that. Let's rainbow this up. We're going to do red first. Right? Red is going to be our number one. We're going to take apart our substances. I'm going to uncrisscross these things. I'm going to take them apart. First I notice, okay, I've got 2 polyatomic ions. I've got to capture those in parentheses. Then when I look at what ions are made up here, right, what ions do I have? I've got an Na plus 1, an NO3 minus 1. I've got K plus 1, SO4 minus 2. Those are my ions. I have taken apart our reactants. The second thing I need to do, my second step here, is to swap partners. I need to take the Na and the K and swap them. They cannot remain paired with what they were paired with. They have to get new partners. So on the other side of my equation, I'm going to end up with the K paired with the NO3 and the Na paired with the SO4. Then I have to put them back together. I have to bring these and put them back so I could put them into the equation. I need to crisscross back downwards. K1, NO3, 1, which simplifies to just KNO3. Na2, because this 2 is going to come down. SO4, 1, which just simplifies down to SO4, right? No parentheses needed there. Then I want to balance my equation and check table F. Right, the balancing here, I've got 2 Ks, but only 1 K here. I'm going to need a 2. This 2 means I've got my 2 Ks, fantastic. I need 2 NO3s, but I only have 1. So put a 2 in front there. 2 NAs, and I have here 2 NAs, great. 2 NO3s, and I have here 2 NO3s, great. 2 Ks, and I have here 2 Ks, wonderful. 1 SO4, and on this final, 1 SO4, great. Put in my 1s just to be safe. And lastly, I need to check table F. Do I have any substances here that are solid? The answer is no, I do not. Right, these are both aqueous substances. Both K and Na are group 1 ions. Group 1 ions are soluble all the time, no matter what they are partnered with. So, this becomes my final answer. The thing I wanted to report, the thing I'm going to write down, is this top row here. Everything in... That's not what I wanted to do. Everything in this bracket here becomes my final answer. The full, completed, balanced equation, including my states of matter. Let's take a look at some examples that we're going to let you try. Pause the video here and try a couple of these on your own. Remember your steps. Right, we are going to take apart our reactants. We are going to swap partners. We are going to put products back together. And then finally, we are going to balance and check table F. Pause the video, give yourself some time to work on these. I'm going to count to 10 and I'm going to flip this slide over and we're going to look at some of these answers. So, when we look at our answers here, we end up with these fully balanced equations. The one thing I didn't do because I wanted to work together with everyone on was to make sure that we filled in our table F. Right. When we look and make water, water gets made as a liquid. Right, there are two things that can be made here, right? If we make water, that gets made as a liquid. If we ever make CO2, that gets made as a gas. Everything else in a double replacement is either going to be something that is aqueous or something that is solid. So our waters we want to label right off the bat as liquids. Remember, our group 1 ions are always aqueous. Right, that includes our H, our K, our Na. We don't always need a substance to be, or both substances, sorry. We don't always need both substances to be solid. We don't always need a precipitate. We can have this reaction where it's a double replacement and both things end up aqueous. That's fine. It's not a problem. When we come in and we look at some of these solids, right, that's going to be our silver chloride here. It's going to be our lead sulfate and lead sulfide. We're going to flip back over to the blue because I missed a couple of these. Good aqueous substances. Right. Those are our precipitation reactions. And that's how you do them. You just do a double replacement. We're keeping an eye on table F. We're seeing, did we make something that is going to float its way or sink its way down to the bottom of the container? Did we make a solid, or is everything aqueous? Did we make more water? What did we do? And with that, we're going to stop our lesson. Next time we're going to wrap up this small unit. We're going to talk about colligative properties. We're going to talk about, well, what effect these dissolved ions have on the properties of water. How does that change the solution itself? But that's all for now. Have a fantastic day.